Thanos on a mission, big data on a roll. Scaling up the system, monitoring the whole. Extend Prometheus far, long-term storage bright. In every data bar, Thanos shines its light. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it live. Metrics never fail, infinite surprise. Thanos on the trail. Data flows like rivers through the nodes and streams. Thanos chills the quivers, fulfill all our dreams. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it live. Alerting on the rise, metrics never fail. Infinite surprise, Thanos on the trail. Thanos on a mission, big data on a roll. Scaling up the system, monitoring the whole. Extend Prometheus far, long-term storage bright. In every data bar, Thanos shines its light. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it live. Metrics never fail, infinite surprise. Thanos on the trail. Data flows like rivers through the nodes and streams. Thanos chills the quivers, fulfill all our dreams. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it live. Alerting on the rise, metrics never fail. Infinite surprise, Thanos on the trail. Thanos on a mission, big data on a roll. Scaling up the system, monitoring the whole. Extend Prometheus far, long-term storage bright. In every data bar, Thanos shines its light. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it live. Metrics never fail, infinite surprise. Thanos on the trail. Data flows like rivers through the nodes and streams. Thanos chills the quivers, fulfill all our dreams. Scalable forever, we can't stop this drive. Monitoring together, Thanos keeps it alive.
Hey, welcome everyone to the very first episode of Project Spotlight. We're thrilled to kick off this series with Saswata Mukherjee, who will provide us with an in-depth overview of Thanos. Swataji, could you start by introducing yourself and share your role within the Thanos project?
Sure. Hi everyone, and thanks Steve for having me. My name is Saswata Mukherjee, and I'm a software engineer at Red Hat, currently based out of London. And I've been with Red Hat for about 2.5 years now, and I primarily work on monitoring platforms. So we deploy Thanos internally, and different teams send us metrics and query them from us. We also ship Thanos as part of some of our products as well. And I'm also a maintainer of Thanos, and I have been so far around a couple of years now, and was previously a Google Summer of Code mentee under the same project as well. And now I help maintain it, mentor projects around it, and I maintain a few CNCF adjacent Go tools and libraries as well. That's me.
That's great. Thanks very much for being the inaugural presenter of the Cloud Native Project Spotlight. So the floor is yours to dive into Thanos. Could you walk us through its purpose, kind of how it extends Prometheus's capabilities and the key features? I know for one, I'm excited to hear more about the changes that have been made to Thanos over the last couple of months. I'm a long-term user of Thanos, so I'm excited to hear more.
Amazing. Again, thanks for joining everyone, or if you're catching this later, hi. I'm really excited to present Thanos in this inaugural video for the Spotlight series. I wanted to give you a brief intro into the technical aspects of our project, and then maybe some updates and how to get involved, right? It's a good idea to start with the base of Thanos, which is Prometheus. And if you aren't familiar with Prometheus, it is a CNCF open source project for systems and services monitoring. It was inspired by Google's internal boardmon tool and kind of offers a time series database with a sort of multi-dimensional data model, which uses labels, and it stores this locally on its disk and allows querying from PromQL. It scrapes metrics from your application using the pull model and stores everything in its local TSDB. So if we were to explore Prometheus a bit more in depth, we can say that Prometheus functionality is basically composed of 4 different internal components, right? Namely the scrape engine, the query engine, rule and alert engine, and maybe the compactor. And so the scrape engine is what is responsible for scraping data from your applications and storing those metrics from different applications in the local TSDB. The query engine processes PromQL queries that you fire through Prometheus UI or Grafana, and then selects that data from the database and returns that. The rule and alert engine are actually what evaluate PromQL-based rules and alerts. So rules can be used for dashboards, alerts can be like sent to Alert Manager, and so on. And then the compactor is finally a sort of like background process in charge of doing leveled compaction on the time series database blocks for faster queries, right? However, as amazing as Prometheus is, it does have certain limitations. It is a single process, so you can hit vertical scaling limits pretty quickly. You would lack a sort of global or single pane of glass query view for metrics across all of your different infrastructure, clusters, workloads, etc. And in case you run Prometheus in sort of like a high availability pair, you would lack the ability to like deduplicate metrics between them. And not to mention things like long-term retention as well, where you can use Prometheus to store metrics for longer periods of time, but that would be very expensive, right? And so on. And this is where Thanos kind of comes in to essentially save the day. So Thanos can be termed as a sort of distributed Prometheus plus plus, and that's for good reason. Thanos's goal is to provide a highly available and scalable toolkit of components that allow for composing a distributed Prometheus-based monitoring system. And so it tackles many of the challenges associated with running Prometheus, right? And so let's explore one by one what those challenges are and how Thanos can solve them. Starting with the most important facet of these challenges, which is the global query view. So global query view basically refers to this ability to query and aggregate metrics across all of your logically or physically separated infrastructure. Now, if you have logically or physically separated Promethei, there's usually no real way of aggregating data across those instances or aggregating metrics across those instances by firing a single PromQL query, right? And so this is where the Thanos component called the Thanos query or the Thanos querier steps in. And it replaces the query engine part of Prometheus in a sort of distributed setup. It is like a stateless and horizontally scalable component that allows processing PromQL queries against various different metric storages or metric backends. And then it supports aggregating data from those backends or optionally deduplicating the data from those backends and answering your PromQL queries. But a question that you might have is like, what is a metric backend? Well, in Thanos, this can be any storage that implements the Thanos gRPC Store API. And this is basically a gRPC API interface used by the querier to efficiently discover and select data from various types of metric data stores or metric backends. And this is basically the magic glue behind Thanos. And this is how querier can reach out to your different stores and get the series, the label names, the label values, and so on. And so we can solve our problem by connecting our Prometheus instances as metric backends to the querier by exposing a store API on top of them. And we use this, and we use the Thanos sidecar component to do this. And it's aptly named because it is deployed alongside every single Prometheus instance, and it uses the remote read protocol to expose that TSDB data. And this effectively replaces the scrape engine functionality of Prometheus in a sort of distributed manner, right? So the sidecar can also upload Prometheus TSDB blocks to object storage, reload Prometheus configuration files if needed, and I believe you can actually deploy the Thanos sidecar with Prometheus Operator as well. So with the querier and the sidecar in place, we now have a global view of all of our metrics across different Prometheus instances, and we can run aggregations on them. We can even take advantage of native deduplication within the Thanos query or the Thanos querier with the setup. So you can have high availability pairs of Promethei, which maybe scrape the same applications, but you can deduplicate data between them. You can also expand setups like this as well and run a tree of Thanos queries where the leaf nodes would be sidecars or metric backends. The children would be Thanos queries and the root would be a root query, which gathers data throughout that tree as well. So with that out of the way, we arrive at our second challenge, which is global rules and alerting. Now we can query metrics globally, but what about our alerting or our recording rules? While a lot of this can still be configured on your existing Promethei or Prometheus instances, there are times when you might need or might want a recording rule or alerting rule which aggregates metrics across your entire fleet, across different Prometheus instances for fleet-wide dashboards or fleet-wide alerting, right? And we already have a global query view with the queries, so we can actually leverage that here. And we introduce a new component known as Thanos Ruler. And so Thanos Ruler basically evaluates Prometheus format recording and alert rules against any particular Thanos query endpoint. And then it stores the result of that evaluation into a local Prometheus format 10-series database. It also exposes a store API so that it can be queried back by the ruler, so you can still query your rules and alerts. And it is capable of sending your alerts that have been generated from your alerting rules to alert managers. And it also uploads its blocks to object storage. So with the ruler in place, we now have global rule evaluation. And this means that we can create recording and alerting rules, aggregate metrics across our different Prometheus, and get global data for fleet-wide dashboards or for alerting. Now, let's talk about a slightly different problem or challenge that Thanos tries to solve, which is long-term retention, or to store the metrics that you scrape for longer periods of time. We have global view, but what if we want to store and query our metrics for, let's say, a year or more? The use case for things like this could be analyzing trends over your infrastructure, annual billing metrics, or even like quarterly or yearly SLO measurements and things like that. But persisting this much data has its own set of challenges, both computational and financial, as persisting that much monitoring data on your SSDs would end up very expensive, right? So we can actually take the help from object storage. And so object storage is usually available everywhere across different cloud providers or even on-prem these days, and it's very cheap compared to SSD storage. The only trade-off here is speed, but for historical metrics, that trade-off is acceptable. And so Thanos components like the sidecar or even the ruler will come with a background object storage shipper, which would basically ship off TSDB blocks once they're cut on disk after some time, and then those TSDB blocks get into your object storage bucket. So we can upload all that data in object storage buckets, and we have it in the form of TSDB blocks. But how exactly do we query those blocks then? And then here we introduce a new component, which is the Thanos Store or the Thanos Store Gateway. And so this component also exposes the Store API and is a metric backend, but it does so on top of the data within your object storage bucket. So it acts as an API gateway and only maintains an index of all the TSDB data present in your bucket, and continuously syncs with your bucket to scan for newer blocks. And Thanos Store looks at all the data in your bucket by default, but you can partition it to only look at a certain time range of data and thereby have sharding on your store gateways, and you can make it highly available by running multiple replicas of those shards as well. So with the store gateway in place, we are now able to query data with virtually unlimited retention from object storage. So for recent metric data, query would use the sidecar or maybe the ruler store APIs, and for historical data, it would use the store gateway store APIs, or a mix of both if that is what your PromQL query needs. But another problem that you might have with this is query speed, especially if you query for higher ranges of data. You might end up loading like a billion samples, which is definitely a lot of data to show in a graphical UI, or you might just be querying too many short blocks. To address that, we have our fourth challenge, which is global compaction. And with this much long-term retention of metrics and blocks, we need to have some form of leveled compaction. And this is like a Prometheus part, but essentially we need to compact our blocks to shorter blocks to like longer range blocks. So compaction refers to the process of creating longer duration TSDB blocks from one or more shorter duration blocks. And at the end of each compaction cycle, the source blocks would get deleted and the new compacted block is used in place of those source blocks. And so the Prometheus TSDB usually creates blocks of, I guess, 2 hours after ingesting the latest script data. And these 2-hour blocks can then get compacted to longer and longer time ranges, and the original blocks get deleted. This TSDB compaction is taken care of at a global level within Thanos by the Thanos compactor component. And so compactor will look at your object storage and will identify streams of blocks or blocks from the same source, and then perform compaction to merge blocks within each stream. And so this helps speed up larger queries as they need to now look for less block indexes when querying. It is also in charge of setting something called retention, which is basically how long you want your blocks to remain. You might choose to, let's say, not have any data beyond a year. And so those blocks which get too old need to be deleted, and your compactor would be in charge of that as well. Also, this compactor is in charge of something Thanos specific as sampling. And so it can actually downsample the raw data in your object storage from scrape time accuracy, which is usually like one data point every 15 seconds or every 30 seconds, to one sample, let's say every 5 minutes, or even every one sample every 1 hour. And the original raw data is not deleted, but actually kept alongside it. And so this way, when you query for multiple months of data, let's say you query for a year's worth of data, Thanos query will automatically load the lower resolution blocks, and you would still get an accurate graph of the data of the metric data that you have. And if you choose to zoom into that graph, Thanos query will load the raw block duration, and you will still find all of your data present. It also creates some chunks of the most common aggregations, like most common PromQL aggregations, like count, sum, min, max, or average within these blocks, so that you can further speed up your long-range queries, which touch these blocks. And so this makes querying a year's worth of data or more actually viable. So with that, we have now effectively replaced all the internal Prometheus components in a sort of distributed and highly scalable manner. But let's talk more about another new challenge that we need to deal with now, which is using Thanos, but in egress-only environments, or even as an off-the-shelf monitoring as a service solution. The main problem of this challenge lies with sidecars architectural limitations, right? And so firstly, Thanos Query will always need to have ingress permissions to wherever sidecar is running to make story API requests to it. And this might be really difficult to achieve, especially if you have clusters or environments that you do not fully control, but need to get Prometheus metrics from anywhere. Also, if every single sidecar would need to be given access to object storage, that is difficult to configure securely. And a major pain point with this architecture is that it is very difficult to create a monitoring as a service solution where users can pop in dynamically, send their metrics, query their metrics, and ingestion is mostly client initiated. So yeah, those are some of the limitations. And so with this in mind, a new component was designed called Thanos Receive, and Receive is built to implement the Prometheus Remote Write API on top of Prometheus TSDB, which essentially allows you to stream metrics to it, and Receive will then ingest them in a local TSDB. Receive will then also expose a story API on top of that TSDB to allow queryers to query the remote written metrics from it. And so you can configure Prometheus or any other compatible remote write client to continuously stream metrics to it or write metrics to it, and then Receive will ingest that for you and will also upload the TSDB blocks to object storage. And so this component is basically used to receive metrics in a sort of air-gapped or egress-only environment. And so Thanos Receive also implements multi-tenancy based on tenant labels, where that it can add to the time series that you send to it via HTTP headers on your remote write request. It takes scalability seriously too, so you can run multiple receive nodes together in a hash ring, and remote written data is then shared and replicated between different receive nodes. And with Receive, you can now actually receive your push metrics across egress-only network boundaries and ingest them scalably, have some form of monitoring as a service solution. With that said, let's talk about some of the new things that the community has been up to over the past few months. We've had some really amazing contributions and innovations within the project as well. So starting with a few Thanos query features, as that has been the focus of a lot of the work this past year. So the distributed engine has now been released. And what this means is that this was a major chunk of work that was undertaken by Philip, who is one of our maintainers, and several others. And this involved creating a sort of gRPC query API and creating a distributed engine interface for the new Thanos Volcano engine, and then tying it all together within Thanos to get something like this. And so normally a querier would need to pull in all the data from stores before evaluating a particular query. But with distributed execution, a query can be transformed into certain subqueries that can then be delegated to leaf or child queries within a query tree, like we see over here. And so this can drastically reduce the number of series that each querier has to process, as Prometheus results tend to be mostly aggregations. And so the number of series that you would get on your root query would be drastically reduced, and thereby grant you huge efficiency wins. So yeah, and this query is actually rewritten by the distributed execution optimizer in our Thanos's PromQL engine and its associated interfaces. And the distributed execution mode can now be enabled using the query mode equal to distributed flag. So when this mode is enabled, the querier will break down each query sent to it into independent fragments and delegate them to components which implement the gRPC query API, which is basically the Thanos querier. And so this mode is particularly useful in architectures where, let's say you have multiple independent queries deployed in separate environments, like different regions or different Kubernetes clusters, and are federated through into a separate central query. So yeah. Next, we introduced an SQL-like explanation and analysis feature for working with PromQL queries, and this was something that we worked with together with our LFX mentees. So what this allows you to do is visualize how the query engine will process your PromQL query and with what operators, so that you can choose to optimize your queries as you wish by clicking the explain button and getting the physical plan or the query tree for that particular query. And you can then check the analysis checkbox and hit execute to get the same query tree, but this time with the results as well as the query tree executed with and decorated with the amount of time it took for each of the operators to do their work. And this just gives you deeper insight into where your query spent the most time. And so we hope that these can be used in a sort of flow like this, where you optimize your query explanation until satisfied, then execute and analyze the query result before trying to optimize again if you choose to do so. We also introduced the notion of query tenancy in Thanos natively now. So you can fire PromQL queries with a tenant header and then get back only the data of the tenant that you asked for. It's important to note that Thanos can handle authentication and authorization features, as that is completely outside of its domain. But there are OSS projects that you can now pair with this to have a decent query tenancy feature. And under the hood, this uses PromLabel proxy, which is again a community project. So yeah, you can have native query tenancy. And finally, Thanos Receive now supports things like tenant splitting. So you can send remote write requests to it, which have a mix of multiple different tenant time series, and you can specify a label, and it will automatically split all the data in a particular remote write request into different tenant TSDBs on its own without you having to specify a single HTTP header. And this enables things like multi-tenanted rules, etc. So with that brief technical overview out of the way and some project updates, we can talk about how you can get involved with Thanos. And so it's a good idea to start with the people who are involved in Thanos projects and are part of the community and generally have context on what we are doing. Thanos team members who are regularly contributing back changes and keeping track of upstream initiatives, as well as several contributors who help us identify issues and continuously improve on the project. So yeah, these are amazing people to interact with, and it's better to like get to know them. But where can you interact with them? So for communication and for communicating with the community, this primarily happens on the public channels on the CNCF Slack, i.e. Thanos and Thanos Dev. For any code-related discussions such as bugs, issues, feature requests, or even proposals, we like to keep the discussion to the GitHub repo of Thanos. And we have a Thanos org as well as a Thanos community org. So if you're interested in projects there beside Thanos, you can choose to contribute to those repos and link back to the Slack channels to get more people involved, and so on. And we don't maintain a roadmap of Thanos publicly since multiple vendors contribute to it and they have different priorities, but usually you'll be able to find most proposals and issues within the GitHub repo itself. We also have several members of the community participate in events like KubeCons, both NA and EU, as well as PromCons, which I think is the next one is set to happen a couple of weeks from now. We also hosted for the first time ever ThanosCon this past year in KubeCon EU as a co-located event, which was really successful, and we had so many amazing talks from the brilliant people at Cloudflare, Reddit, Shopify, etc. And finally, as a CNCF project, we do quite a bit of mentoring externally, and mentorships are really important for a project like us since we get to onboard the next generation of developers and get them interested within this domain. And this also helps us grow more as maintainers. And we usually have CNCF LFX mentorships every quarter of the year. GSOC, I think, happens once a year. And we'll try to come up with projects and propose them via CNCF. And we try to pair as maintainers, as mentors for this project and try to help our mentees not only technically, but to grow more as a sort of open source engineer. So yeah. Yeah, that's it. Questions, comments?
Before we move on to the general Q&A, I asked.
Steve, I think you're muted.
Can you hear me? Are we good?
Yeah, I can. No.
Cool. Yeah, before we move on to the general Q&A that the audience can ask, I asked our community on Twitter and LinkedIn to submit their questions about Thanos, and the kind of most common DM that I received was, what inspired you to get involved with the Thanos project, and how do you envisage its evolution shaping the future of monitoring in cloud-native environments?
Sure. So it's two questions. The first one I would say is mostly around, so yeah, I got involved through the mentorships actually. I was part of a Google Summer of Code mentorship under the Thanos project, and Bartek, who is the co-author of Thanos, was my mentor. We worked together on a particularly interesting project around some document automation with like a tool called MDocs, and I just got really interested in Thanos at the end. He referred me to Red Hat. I did an internship there and joined as full-time engineer, and now I work full-time on Thanos. When I say work full-time on Thanos, but I also deploy Thanos and maintain certain other things as well. But yeah, that's how I got involved. So I would say like mentorships are one thing. But also, if your company uses Thanos and you want to get involved, you want to contribute back upstream changes to it, or just as a user, you have ideas on like how we can improve, definitely reach out, definitely create issues or reach out to us on Slack channels and discuss with us like what you would like to see happen. And this kind of leads to the second question, which is envision how its evolution shapes the future of observability. And so I think metrics are a very standard pillar within observability, and Thanos just helps kind of scale that pillar to more and more things. We've seen people do some crazy monitoring with Thanos and monitor some amazing setups, and I hope that that would continue and we'd only make it more efficient, faster, and more accessible to SRE personas and software engineering personas. So yeah, that's what I think.
Cool. So Fidelio asks, what is the best way to get started with the Prometheus operator and Thanos?
Both of these projects have documentation with certain quick starts. For Prometheus Operator, I think you have some parts of Thanos. So you have the Thanos sidecar as well as the Thanos Ruler. And so it's mostly a gradual adoption, I would say. So if you start with Prometheus Operator first, you might install it on your clusters and get Prometheus monitoring. Then you might enable sidecar and then run Thanos query separately and try to get a global query view, then expand it with ruler and so on and so forth. So try to adopt as gradually as possible. Both of these projects are amazing. They have documentation, so do refer to that. And if you have any feedback, reach out to us.
Anyone else have any questions before I start asking a couple? Okay, I'll start with an easy one. What areas need the most help within the project?
I would say now query. I would say now mostly the Thanos query parts. There's a lot of things, a lot of features that have been enabled, and it would be good to streamline some of it. Definitely, like we need more people to test stuff out as well. There's also an opportunity to like have something like a sort of benchmarking repo within Thanos, so that you can we can benchmark Thanos every PR and make it more and more performant. So yeah, there's a bunch of things to do. But yeah, I would say the query definitely needs some help before. But yeah.
Great. Another one for me is, what has been the most rewarding aspect of working on the Thanos project?
Yeah, it's amazing because like you get involved with this community of people who are like brilliant and smart, and especially for Thanos, you feel this more because Thanos also has like Thanos depends on Prometheus for a lot of things. And so you get to interact with the people within the Prometheus community as well, super closely. And so yeah, well, I would say what has been most rewarding for me is making friends with the community and getting to know and meet so many amazing people.
That's great. Yeah, if you could go back to the beginning of your work with Thanos, what advice would you give yourself?
Take things slowly and try to learn things one at a time instead of going all the way initially. Because Thanos is a very large and daunting project. There's a lot involved, lots of different components. And so, yeah, that would be my advice, which is like go one component at a time. But yeah.
What do you believe is the next big challenge in the observability space, kind of in general, that Thanos and similar projects need to address?
Mm, I would say like, so there's two aspects to observability, right? One is that you always want the data that you don't have. And so when it comes to things like observability, especially this holds true. Um, so I would say like one of the big challenges is like unifying certain monitoring and signals in a way that is actually human parsable. So like correlating between signals, but also keeping them separate enough that you can extract the required amount of data from each of them. That's a huge challenge. Um, yes, I would say like that's something that the entire observability space as a whole needs to address. But yeah.
Are there any kind of up and coming features or improvements that the Thanos team's currently working on that you can give us a scoop on?
Well, I mean, distributed execution is one thing that I mentioned, the query distributed execution. It's being worked on very heavily. There's already a bunch of people using it in production and are very happy with it, but there's things to improve there as well. There's the Volcano engine, which now supports, I think, most of our Prometheus expressions. So yeah, definitely. Those are parts where we are continuously working. So yeah.
Where do you see Thanos in the next couple of years, and what are your hopes personally for its impact on the cloud native ecosystem?
So what we see is right now for most large companies is sort of clusters as cattle approach, where you have multiple different physically separated clusters and you want to kind of monitor it fleet wide. And so what I hope to see in the next few years is Thanos be adopted more and get more team members from the open source ecosystem and just improve in general, make monitoring much more efficient and give people more insights into their entire sort of fleets, right? So yeah, that's my hope. And I hope it leaves a lasting impression on the cloud native ecosystem.
I'm sure it will. I use it personally on a number of projects that I've been working on in the past. So yeah, I absolutely love it. Yeah, for someone new to Thanos, what resources or best practices would you recommend to kind of get them started? Obviously, you recommended a couple there in your presentation, but are there any others that you'd like to call out?
So obviously the documentation is like one thing to get started on. There's a bunch of talks on YouTube where you can kind of get familiarized with Thanos and its different components. And then to develop on Thanos, we have certain interesting interactive tests within the Thanos code base that you can run to get up and running with Thanos and get a sort of local Thanos system enabled with like sidecars and stores and a query that you can play around with and test changes on. So yeah, I would recommend exploring the interactive tests. And we also have the mentorship programs that you can be a part of and work with us closely. So yeah.
Anyone in the audience have any questions for Seshwata? Okay, Philida says again, what are the best ways to reach out after this video?
Yeah, like the CNCF Slack is where I usually would be happy to answer questions. So yeah, definitely the CNCF Slack.
And one for me, just out of interest, what are you currently working on within the Thanos project specifically?
So yeah, like within Thanos, it's not really within Thanos, but I'm working on a dedicated Thanos operator, which would help people set up Thanos neatly, and so that's what we are currently working on. But that's more of a Red Hat internal thing. But we soon hope to like share it more and release a first version of it. But yeah, that's what me and a few of my colleagues are working on.
Sounds interesting. I'm looking forward to hearing and seeing more of that. You'll have to come back on again once you've got it working.
Yeah, like hopefully it's like we want to like keep it as compatible as possible to the Prometheus operator because that is so widely adopted and loved. But yeah, like something to make deploying Thanos easy across your clusters, right? So
makes sense. Does anyone else have any other questions? If not, personally for myself, I want to say thank you for sharing your expertise with us today. It's been incredibly insightful to learn more about Thanos. There's some things that I didn't even know were possible. I haven't used it for a little while, so it's great to see the evolution of the project and the work that you and the team are doing. Keep up the great work. Yeah, before we wrap up, we're going to start a tradition on the Project Spotlight where each guest leaves a question for the next guest about their project. So since you're the inaugural guest of the episode series, what question would you like to go for the next project maintainer?
Yeah, I would say I believe the next project maintainer is from Pixie.
Yes.
Right? Okay, so from what I've explored in Pixie, they have this query language called PXL. So I'm just wondering what the motivation was for a new query language and to make it, I believe they have some Python bindings with that query language as well. So yeah, like I'm interested in what the motivation for a new query language was and how that helped them.
Okay, Dom, if you're listening, you've got the sneak peek on the question that you're going to get asked. If not, I'll make sure that gets asked in the next episode with Pixie, which is later this week. With that, if there's no further questions, we'll conclude the first episode of the Project Spotlight. Again, big thanks to yourself,
Thanks for
Shaswata.
having me.
And yeah, no problem. And all of you who've joined today. Yeah, tune in next time for another deep dive into, as Shaswata said, the Pixie project. See you soon.